All right. Thanks very much for staying so long. It's already get dark. And thanks for PyCon for great event. It's my honor to give in the final talk. The slides I have not showed to my manager because he might not approve it. After this talk, he might fire me, but that's okay. If I can see the slides. So this is me. When I design system, I put those things on my priority list. Some of the blank side, because I cannot list all the important things. I have been working in this space for a couple years, had been designed and delivered the big data pipeline for Ericsson, 2 Nordic banks, and a third of an automobile company, not Koenigsegg, sadly. So today I'm going to share the work I'm done on HM. Actually, it's the live system. It's not a fake one. Hope you enjoy it. So I supposed to get 45 minutes, but I only get 30. So the tuning part will be pretty short. And I guess you can figure out during the previous slides. So when design big data pipeline, what are the goals? It must be many, many goals. And it depends on who the client is. You can ask many different questions. Different people put different goals. But no matter who the client is, the first and the far more most important thing to me is care. So how good your solution is depends on how good the care your designers have. If with a little bit of care, the solutions might be like this. This is your big data pipeline. If you put much care, then the solution might be like this. Cleaning and tidy. That's what we all want, isn't it? And let's see why big data pipeline is difficult. Lots of people talk about this 5V. I will cover this 5V as well, and a little bit extra. So the first V is the volume. Because why it's called big data? It's big. Lots of data coming in. And a multiple terabyte is not that big in these days. And another thing is the velocity. So the data are constantly coming in on fast speed. For example, there are lots of IoT devices which coming in on second level. And how to deal with it? And another thing is variety. If you open a lady's closet, there will be lots of things box. I even cannot name it what those is. And this is exactly the same as a big data pipeline. They are this kind of data, that kind of data, this kind of source, that kind of source. And the requirement also very different. So how to deal with it is a big question. We all want the perfect data, the data that speak the truth. But sadly, that's not the reality. We want the road to be smooth, but sometimes we get those kind of road. And we have to figure out some way how we can fix those things. But when you talk to business people, they don't care about those velocity, volume, and so on. What they want value. Give me the value. And why big data is difficult? When we talk about traditional software design, it's like spend whole day to write, but when you want to run it, usually only spend a couple minutes. That's totally the opposite in big data pipeline. You spend a few minutes to write, and the whole day to run and wait the result. On some sense, it's good. You can go pick up a cup of coffee, or you can even go back home, and the result will come out the next day. Another perspective lots of people are not talking about is the reliability. How good your system is reliable. So if it's 50%, it's relatively easy. I don't know how many of you stayed in that T-Central. See those shiny escalators. These 4 shiny escalators, usually 2 of them are working. And sometimes 4 are not working. So you can tell your manager, my system, the reliability is 50%, and plus or minus 50%. And as an engineer, I guess you don't want those 50% plus or minus 50%. What I want is 100%. Of course, there is no system is 100% reliable, but we want as close as possible. Then all those questions, how we shall design it, how we shall using a little bit more systematic view. Here I will share some of my idea how to do it. If you like it, you can catch me. And we are also hiring. You can talk to me or talk to some of our colleagues. So the first thing to me is needed layered design. And feels very simple words, but in reality, that's not the case. If you look into your system, especially for system existing for a while, it will be a spider net. It's not a pyramid. So the idea is very simple. The high level will be depends on the low level. And the low level shall never depend on the high level. There are lots of talk regarding to performance optimization. If I can do a small survey, if you want to do performance optimization, which part will you first focus on? The top part? How many say should focus on the top part? No? Okay, 1. Anyone? Then how many people think we should optimize the bottom part? Okay. I have my idea on this one, but I might not have enough time. If we have, in the end, I can share my idea, what's important to optimize in this pyramid. And this is a secret. And that's especially important for big data pipeline. So the idea is that the flow should going forward, but never go back and form a loop. That's not always the case. For example, in Airflow, you design, that's not allow you have a loop. But you can create that one. For example, one step you write a file, then some step you read it back, then you can form a loop. And very nice loop. But that's what not we want. And another matrix. We have lots of matrix. And this is one Airflow graph from our system at one point. So you see that there are lots of steps last pretty long. And some of the steps I say, okay, this is only try to get the result of 15 kilobyte. It took 20 minutes. How can that possibly be? A 15 kilobytes data took 20 minutes. What happened? So the question will be more related to this matrix is not accurate. And a lot of time, they are not doing real work. They are waiting. They are waiting the resource to be available. So if we have those kind of matrix, how will you do optimizations? We have no way. We cannot find which step we should do the optimizations. And the duration is only one perspective. There are much more. So in the whole running duration, there are matrix, for example, how big is the CPU, and the memory, and disk, network. And now in cloud world, those things can be calculated as money. If you allocate a big CPU, but you're only using tiny, that's waste of money. If you want, you need using big memory, you only give it small, no matter how other characteristic you have for the virtual machine, it will be slow. So how to get those one? You need to get the right, accurate matrix, enable for you to do optimizations. And when we do the design, we say, okay, that should be testable. For example, this door handle. I guess lots of you see this door handle when you lock it. Is it really locked? Wait until someone outside test for you. So we call that we take test seriously. And once we test in production. And this is PyCon, so I'm supposed to show some Python code. So I write 8 lines of code to show you an example, a test one and a non-test one. And that's real example from some of the code base. So it's like that. So there are 2 functions. The first, mumble data, is a data frame and a bunch of other arguments. Then first using getDF from some of the argument you pass in and doing a join. Then write to somewhere. Then said, okay, I'm finished. Then the question is how I'm going to test this function. The getDF is very much depends on how you passed in the argument. And the write that one is somewhere else. And it's no way to test it. And the next few lines is very simple. So that a testable function should have a clear input and a clear output. Ideally should not have any side effect. If you have side effect, when you first run is this result. When you second time run it, for example, the first function, it will fail. Why? Exactly. So this word is quite difficult to pronounce. Well, re-emponent something. So which means no matter how many times you execute it, you should expect the same result. And the first function is not. So that to me is not a testable function. System like Airflow, it has an lineage or the task lineage, but that's only the task executions. If you don't have a well-captured way, that will be only the task lineage. What we want is more of the data lineage. So how the data passed through, how that is derived. For example, this is the one I blurred because it's a real one. And from this simple graph, you can see that, for example, which data frame is worth to snapshot. If that need to be reused in multiple places, then it's worth to snapshot it. Otherwise, most likely, no. If on this graph you add some extra information, for example, how big the data frame is, how big a partition is, then you can know that, okay, that one take 2 hours. I will optimize that one first. That one only have 15 kilobytes. Should I do optimization on that? Certainly not. And then beside all that, detail matters. How many bricks you lay it up? If you only lay 3, then it's likely it will stand. If you lay 100, then every screw and bits and bolts need to be lined perfectly. Then another perspective is that we have a role called data scientist and data engineer. And I guess that most of us want a clear border. Okay, data scientists to do that part, engineering do that part. But they are usually will be an invisible border, which is not that clear. Like this. Even you define clearly in words, it will be always have certain border. So how much you care? If you care, you might move a little bit that side. So try to help each other to make a better solutions. And I'm going to share you one of the solutions and very opinionated solution. You might agree with me, you might not. I got lots of argument. They certainly not agree with me. So this is bullshit. You should not do that. Anyway, this is one of the solutions. A real one. So we have Jenkins as the continuous integrations and Airflow as the orchestration layer. Then have multiple notebooks. We are using Databricks because they offer quite a good of service. So as an engineer, I don't need to do much, only need to do a little bit. Then this notebook that everyone can run, data science either using like Jupyter Notebook, Zeppelin, and Databricks, they are basically the same. What you want is first run that, then run that. Only 3 notebooks, your task finished. That's it. And not like you need to write 100 lines of code, try to tune it, then finish. So that's why comes of these solutions. And some of the other tasks might not worth using notebook, might using, for example, I want a powerful GPU with the most latest cutting edge technology with the bug fix in the latest branch, then it's likely it's easier you using a virtual machine. You have the full control. And with all those, if all those steps have the common storage, for example, store the data into data lake, then they are interoperable. So you can figure out how I should split the notebook, which notebook is running what kind of cluster is more suitable. For example, lots of cluster, we want like a huge cluster with lots of memory for data preparations. But for the model training, it's likely GPU is the most relevant one. So based on the previous, I said this matrix, you can say, okay, I want to use that cluster. If we have all the matrix stored in the history, we can do lots of things. For example, we can do alarming. Yesterday, there are 100 million rows. And today, when I run, it only come 1 million row. What happened? Like those situations, we can always pre-alarm it. As previous slides, we want data science engineer to have a little bit clear role. So that's why I also want some kind of definition of between data scientist and engineer have their own environment, kind of. So for the data scientist, the notebook environment is most relevant. So should have this relevant notebook spread to like ETL job and have multiple different models and doing processings and some other extra tasks we have to do on virtual machine with a real controllability. Then there are a little bit environment we can prepare by engineer. For example, we have the continuous integrations. We have the storage for the code, for the configuration, and so on. Then the production environment should be ideally exactly the same as the data science environment. But of course, there are some extra tasks. Data science does not need to care. For example, I want continuously pulling, say the first step is finished or not. That don't need care. And then doing the later part might also not care. Then we can do in other part. And then we also can add an airflow in, because airflow has a very nice feature. When it's failed, it can be resumed. It can retry multiple times, depends on your configurations. So in this isolation, so that we can get an environment very close and very user-friendly, don't need a lot of understanding of programming. Even project manager can do that. And when we have a model, a variable, sometimes we need like try to optimize it time over time. So what's the way will be that you choose the base, which base you want to run. And then you can say, okay, that function costs the most of the time or have low performance on the accuracy, for example. Then you can copy that code to notebook, try to modify a few lines, run it to see the result. If it's good, fine. If it's not good, we can continue modify, because notebook has this advantage. It's more interactive. You can repeat again for that single step. If you write in Python, you try to run it, the data is gone after your program finished. If you want to do all the previous steps, do it again. Then after we find out this optimized model, then we can involve more engineering. This code can be changed a little bit. This method name might not be correct. Add more comments, for example. Then try to put back to two parts. The notebook is the high level of orchestration work and the low level in the Python code. We have like just the right Python code in a notebook. Depends on how big your notebook is. If it's over 10,000 rows, it will take quite some time to scroll it to find your method. That's why we split to 2 parts. And we can add to this direct acyclic graph to be more productionized. And doing a new model is very similar. Just we can have a skeleton, and based on that skeleton, you read some paper and copy those papers' code, get into that skeleton notebook, or you go to some GitHub repo, get that piece of code, get in, and try to run it, tuning it, and once you feel finished, we can try to put into engineering track to be more operationalized. So with all those words, let's going back to the most important thing. Care. You care your system will care you. And lots of interesting things, just the detail. For example, we want the layer design. We want 100% acyclic, no loop at all introduced. And all those matrices, we should automatically generate it and collect it. It's not that when I say, oh, performance not good enough, sorry, no matrix. And every function should be testable. And we should have this holistic view. And then with all that, we can care all the details and get the best solution. This is me. I organize some of the meetup events as well, called Knock Data, like Knock Door. So roughly has once a month related to either big data, machine learning, DevOps, those related things. If you interested, you can join us. There will be the next one will be November the 12th. Will be related to the streaming. You can add my link in. Or if you're using, by chance, using WeChat, you can scan this. Then, thank you. If you have any question, I would like to take.
So, any questions? Raise your hand, no?
It's too late, I guess. People don't want to have questions.
All right. In this case, thank you very much for your talk.
Yeah.
Yep.
Thank you.